Hello, everybody. This video is to help us think through the answer that we got to the example problem in the previous two videos. In particular, this is designed to help us think about the difference between temperature and heating. In that last example problem, we ended up with a situation where a system of gas particles inside of the cylinder gave off heat. The heating flowed outside of that cylinder to the environment, while at the same time, the temperature of that gas in the system increased. And so we want to think about how that can be possible. So we've got a little bit of an animation here, which I hope helps. The first animation is going to be something a little bit different, which will help set up a contrast where we can look at that situation. So first scenario, let's look at what's going on. We have a cylinder. We have a piston. We have a color gradient that represents temperature, the purple down here being cold temperatures, and then the red being hot temperatures. And this is the temperature for this gas that's in our system. And then this color gradient represents the temperature outside of our system. Notice that the temperature of the gas in the system is at this yellow sort of a place on the color gradient, while the temperature of the surroundings are at this purple place on the left. So the surroundings are colder than the system. I also drew in, using some fancy art here, some thermal insulation. I'm trying to represent like that pink insulation that you put inside of a house to thermally insulate it there, but thermal insulation can be any number of things. This is going to represent a compression with no heating at all. There's no flow of heat because of that thermal insulator. Later on, when we talk about different thermodynamic processes, we will define this as an adiabatic compression, a compression with the absence of heat flow. So if we've got a net force that's pushing on this cylinder, applying some working, this will move to the left, and at the same time, this temperature will increase. So watch those two happen simultaneously when I click here. This pushes in, this temperature increases. Let's go. So as we push, the temperature increases. And in this scenario where there was a thermal insulator, the temperature increased all the way to the red part of that scale. In the Veritasium video that I asked you to watch, this would be a case where the cotton would be able to ignite. Now, let's look at what happens now when we remove the thermal insulator. Same scenario, we're going to compress the piston and the gas inside of our system is at a yellowish temperature, whereas the gas outside of our system is at a purplish temperature. And so let's think about the two different things that are happening. As this compresses, the temperature for the gas should increase. However, with the removal of that thermal insulator, hold up, I've got a mislabel here. Let me delete it. That was copied over from the last slide that no longer applies. So this should increase because the piston is compressing the gas. However, because this temperature is at a hotter temperature than the surroundings, we should also see a flow of energy from the system out to the surroundings because of that temperature gradient between the system and the surroundings. So I'm going to watch this a few times to watch everything that happens. So let's go. What happened there was this pushed in, this temperature increased, this temperature also increased. And maybe importantly here, not maybe importantly, we should note that even though this temperature increased, it only went from yellow to orange without the thermal insulator, as compared to when there was a thermal insulator, it went from yellow all the way to red. The temperature still increased, but it didn't increase as much because there was also a heating transfer of energy outside of the system, which warmed up the surroundings. Let's watch that again. So both temperatures increase, but there is a heating that happens from the system to the surroundings because this system is always warmer than surroundings at any given time, but the temperature here is still increasing because of the working that's done. Let's watch that one more time. And if you need to, you can go back and pause and rewatch this video until you're on board with everything that happened there. But let's label it. The temperature increased, but not as much as it would have with a thermal insulator. So there was still a temperature increase, but less so than the case with a thermal insulator. So the key idea is that even though the system's temperature increased, heating left the system because the surroundings were at a colder temperature than the system at any one given snapshot in time. I hope this video helps differentiate between temperature, which is a variable that defines a gas at any one state in time, and heating, which describes a process, a transfer over time. So I hope these all help, and have a great day.